Whilst this channel usually concentrates on digital FPV, today we're going to talk about analog, and specifically the new Foxeer Reeper VTX Extreme. This is a 2.5 watt analog VTX. In this video, I'm going to give you an overview of its features and capabilities. We're going to tear it down, and then we're going to test its power output on my Immersion RC power meter. In fact, we're not going to test one, but we're going to test two, and I'm going to share with you the results of those tests later on in the video. Just to be clear, Foxeer have sent me both these VTXs for free. However, they have not seen this video before it's been published, and as always, my thoughts and results are entirely my own. I also want to say that there is no flight footage in this video. It is a bench-based one, and I will be concentrating on this VTX in flight in the next couple of weeks, and I will share a video on the channel once that's ready. And if you're interested in seeing that, please do make sure you are subscribed. Anyway, let's get on with it, and let's take a closer look at it first of all. Okay, so as you can see, I have two of the Reeper Extreme VTXs. We have identical units other than color, and the idea of me having two is to allow me to be able to test one in a frame, but then do a bit more bench testing as well. Now, if I lift the lids, as I've said, the only real difference between these two is color. One of them has come in all black, and the other ones come in with a combined green and black chassis. If we just take a closer look at this one here, you can see the unit itself is 36 by 28 max, which is out to the button, by 7.6 mil tall. It weighs 13 grams and it has a 20 by 20 mounting pattern located in the middle, but this doesn't go all the way through. If you look on the back of the VTX, there's no holes. What you have is M2 holes, which go down to about 2.5 mil, allowing you to mount it that way if you want to, so putting screws through the frame into the VTX to hold it in place. Now, this unit supports a maximum power output of up to 2.5 watts. We'll take a look at that in a bit more detail in a minute. I've actually done power testing on both of these VTXs already, and I will walk you through the charts on that to show you the results that I'm actually getting. When you get the VTX, though, it is worth noting that it doesn't come with the full output power available. It comes locked, and in the bottom of the box, you do get this little leaflet, which if I just grab that there and tip it out, this little card shows you the channel selection available on the VTX on the back and how to unlock the VTX on the front. Now, to do that, you simply do it via the included button. There are some LEDs on this which give us indication of what the VTX is actually doing. So for instance, LED 1 is channel, which is green, LED 2 is band, which is blue, and LED 3 is power, and that allows us to select the output power. To unlock it, it's fairly straightforward. You simply press and hold this until you find that the red LED goes on, off, and then back on again, and the VTX will unlock, and then that will allow you to step through the different power outputs, pressing the button, and we'll take a closer look at that in a moment. Now, this unit is aluminium cased, and it does give you some cooling on the top with that built-in heatsink, but it is worth noting that this unit does get very, very hot in use, and again, that's something you're going to need to take into account when you are going to be mounting it. It supports a power input of 7 to 36 volts, and it has a 5 volt camera output. You can see we've got the pin out for the wiring on the side, and they do include a harness with this as standard. We've got video, ground, 5 volt out for the camera. You've got a tramp connection, GND ground, and 7 to 36 volt in. It supports up to 40 channels, and if we take a look at the card, it has all of the usual selections available. So a band A, band B, E, F, and race band. And then if you look at the bottom of the card, it shows you the power output modes that are available. It supports pit mode, 25 milliwatts, and then when you unlock it, it will do 200, 500, 1.5 watt, and then that maximum up to 2.5 watt. Although it's worth making sure that you are flying it legally depending on what the regulations are in your particular area. The unit does have a built-in microphone, which means you're going to be able to get audio from it as well, and its power usage is about 1.6 amp at 9 volts in my tests, and about 1 amp at 4S 16 volt. That is a bit more than what was being said by the manufacturer, but on my supply it is drawing about 1.6 amp at full power. Now, antenna-wise, the unit uses an MMCX connector. They don't include a pigtail in the box, so you're either going to need to get your own or use it with some MMCX antennas, such as the ones I've got here from Foxeer. This is what I'm going to be using to test the VTX a little bit later. Other than that, externally, there's not a lot else to see. You can see on the bottom, we've obviously got the logo. What I will say is you're going to need to make sure that this VTX gets plenty of airflow in use, and we'll take a look at that a little bit now when we power it up in a moment, because not only does the top side get very hot, but the bottom side does get hot too. What I'm going to do is get it connected, and then I'll walk you through how to change the settings on the unit over here. Then we'll take a look at the power output as I've measured it with my RF power meter, and then we'll get the lid off it and take a look at what the build is like inside. Okay, so I've now got the VTX temporarily hooked up. We have it connected to a Foxeer camera, and then we've got the power supply over here. The included harness has obviously positive, negative, and the white wire for our tramp. And then we have a separate bit that comes off that goes to our camera. It does have a pre-wired end on it, and if you're using a Foxeer camera, it will simply plug and play. Now, when you get the VTX, as I already said, it does come locked. You can tell that by the fact that that red LED is on solid and isn't flashing. To unlock the VTX to allow you to get all of the other power outputs, what you need to do is press and hold the button here until the power LED comes on. So it's gone off. We'll wait for it. Comes on. It will go off, and then it will come back on again to signify that we've unlocked it. We'll just wait there. There we go. I'm going to release. And now you can see, rather than that power LED being on all the time, it's now gone off, which is telling us it's both unlocked and we're on power setting 1. Now, to change the settings on this VTX is fairly straightforward. As I've said, they include the little card that gives you all of the information of the bands and stuff. And just to walk you through the way you change the settings, what you do is you press the button once and you'll see it will change the green LED from 1 flash to 2 flash. Green signifies channel, so we've changed from channel 1 to channel 2. I can press it again, flashes channel 3, flashes channel 4, and you can do that all the way through 1 to 8. If you leave it, it'll then go back to sort of the standby condition for it, telling us what the current status is. So now at the moment you can see it's flashing that LED 4 times, and then you can see that the blue LED is flashing as well to signify the band that we're on, and the red is flashing to tell us the power level. To change the band, you would press and hold until the blue LED comes on, and then you can simply scroll through that to get to the band that you want. So that's band 1, band 2, band 3, band 4, and then we want band 5 for race band, which we're on now. And then if I wanted to change the power, what you would do is press and hold the button again until the power LED indicates, and this will then allow us to signify switch through the power levels. So if I press it once, it flashes twice for the second one, 3 times for 500, 4 times for 1.5 watts, and 5 times for 2.5 watts, and then back down to 25 milliwatts. So that is how you change the settings. You first of all need to unlock the VTX, and then you need to actually configure it. The next thing we're going to do is take a look at the RF power levels that these VTXs are outputting. Now, at this point in time, I have already done a bunch of testing on both of these. I've put the data for this into a chart, and I'll put that up on the screen in a minute and walk you through what the results are. What we will though do is a live test as well on the black one, just to show you as well. There are though some things I want to make you aware of before we do that. The VTX is connected to the Immersion RC RF power meter. You'll see that my screen is a little bit damaged. Ignore that. It has no effect on the meter itself. It's been independently tested that it's working as it should be. There is a 10 dB attenuator in the middle. Ideally, I'd want to be using a 6 because that is what is recommended by Immersion RC now. However, the 10 dB is fine. Again, I've already validated this on an analog setup and it's working as expected. Now, when measuring RF power levels, it is worth noting that you should never take any numbers as absolute fact. Whilst this meter is very good, it isn't lab grade, and the numbers that you've got are an indication. They should never be taken as absolute fact. You will find VTX's varying output and setup can have a dramatic effect as well. In fact, in my testing, there was a point where one of these connections was just literally less than a touch of a turn loose, but but that had an effect on the output. So you do need to be aware of all of these things. It's also worth noting that all of my tests have been done on channel 1. The reason for that is these units output the most power on race 1. The higher up the frequency band you go, the lower the output goes. It isn't a dramatic difference, but at max output, it can be up to 200 milliwatts difference between race 1 and race 8. The reason for this is that most of the RF power amplifiers that are used in devices like this and digital VTXs are tuned for Wi-Fi bands, which is a little bit lower than we're used to using in FPV. And as a result of that, the higher up the band you go, the lower the reading. So the safest way to measure output on these is always on race 1. That should be the channel that gives you the best overall indication of the power output. And whilst you will lose output as you move up the band, that isn't particularly anything you should be concerned about. So what we're going to do is power this on. We're going to power on my immersion RC power meter. We're going to power on the VTX. It should be currently set on race band channel 1 on 25 milliwatts output. We'll just confirm the settings on the meter are correct. We're on 5650, peak settings, 10 dB attenuation. That all looks fine. Now, as the VTX is cold, you'll see that we're getting an output on 25 milliwatts of about 36 milliwatts. It does drop to about 30 milliwatts once the VTX gets hot, but my tests have shown that it is a little bit over on that mode. Next, we'll move up to 200 milliwatts. So we'll just wait for the indication to change and we'll move up through the power settings there. So we'll move up to 200. You can see that it's reading 281. We'll move up to 500. You can see it's reading about 660, 650. If we then move up to the next one, so wait for it to configure, 1.5 watts, you can see that it there is reading about 1.9. And then if I go up to 2.5 watts, you can there see that it is reading 34.5 dB, which is 2.84. Now, this reading is cold because the VTX has only just been powered up. I do have a fan here blowing air over it just to show you that. It's a PC fan. However, it does get hot very, very quickly. And as it does get hot, you will see that level drop. As I've said already, it is also worth noting that you will get lower output on the higher channels. So for instance, if I move this up the channel band and if I move it up to say channel 8, there we go. And then if I reconfigure the power meter to go to 5900, because remember, you have to change the power meter, you can now see that the output has dropped to 2.47. Again, about spot on. But if we then go back to channel 1 and then reconfigure the meter back to channel 1, you can now see it is showing a little bit higher. It will vary between the band and the channel you're on, but you should expect to see a drop in output as you move up the band. As the meter has now warmed up, all of the connections are tight, you can see that it's now settled about 2.51 watts. Now, just to walk you through the data that I've collected on both VTXs. Number one is the black VTX, and here you can see the tests done with the VTX left to stand for a period of time in each power output. You can see at pretty much most levels up to 1.5 watts, it does actually overshoot a little bit, with 1.5 watts showing about 1.79, with 2.5 watts coming in pretty much on the nail. I did go back and retest this VTX at the lower power levels, 25, 200 and 500 milliwatts without the attenuator, just to see what the differences was, and the results difference was negligible. It wasn't even worth me making a second chart with them on. It is worth me mentioning that these are the settled results, as I've said. Some of the results you get at first power up, the peak numbers actually are a lot higher, and I have seen this VTX hit nearly 3 watts at peak output when cold, but it does then drop and settle down to that 2.46. Next, if we jump over to the second VTX, the green topped one, the numbers are again very, very similar. This one is a little bit closer in the 25, 200, 500 and 1.5 watt range, but again, absolutely spot on the 2.5 watt number. Putting them both side by side, you can see there is a slight difference between them, but overall it is negligible. So at this point, I've got no reason to be able to doubt the numbers that Foxeer are giving us. Everything looks as it should be. Next, what we're going to do is get the cover off one of these. We'll get it under the microscope just to have a quick look before I give you my final thoughts. Okay, so I've removed the screws from the VTX and we're just going to pop the cover off. What you'll find is that it actually flips out upside down like that, and then the top cover or the bottom cover actually removes and it leaves the board attached to the heatsink area. Now, looking inside, you can see we've got a couple of areas of interest. We have here the main power amplifier, which we'll take a closer look at in a second, and then over here we've got the chipset. If we just gently grab this heat transfer pad, there is one of these also attached to the lid as well, which went on the power amplifier. So the two devices that are cooled are the PA, which is here, and then the main chipset. If we spin it round, the main chipset on this is the RTC 6705, which is rich wave, and then the power amplifier on this is an SIGE, I think that's SIGE 5004L. So SIGE 5004L. If we look at the circuit, what we have is the main output coming out of here from the rich wave chipset. Then it comes down here. You can see there's a matching circuit into the PA, from the PA out to the MMCX connector. If we look over here, you can see the microphone that is built in. We've then got a coil over here for the power circuit. We've got then what looks to be additional power stages here. So we've got another coil down this end. We've got diodes here for input protection, a couple of capacitors. So what we've got over this side is power regulation. You've got another coil up this side of the board here. We've obviously got our power button, another diode there. This circuit up here, probably communication. I'm not sure what that chipset is. If we just rotate it round, it's, I'd say, an SO33 PHVC 2057. Not sure what that is off the top of my head, but could be power regulation, but there's no coils around it, so I wouldn't expect that. That's possibly one of the communication ICs for the built-in tramp functionality. Overall, if we're looking at the build quality, it looks good. No concerns at all. All the components look straight. There's no signs of tombstoning. Everything looks very, very nice indeed, with everything laid out quite well. Now, if I just slide the board off the back cover, it isn't actually attached to it. It's just there with some heatsink compound. And on the reverse side of the board, you can see it's all cooling. So we've just got some large copper areas, some wires going through, and it is just all cooling for the power amplifier side of the board. So again, there's nothing on this side you need to worry about. When it fits in, it simply just then slots back on. And then there's a very, very minimal amount of thermal paste that's then helping cool it to the other side. Now, just looking in a bit closer, just to look at the quality of the manufacturing, everything looks absolutely spot on. As I've said, all of the components look soldered well, no signs of tombstoning. Obviously, I can't comment on the longevity of the product from a design point of view, but from the manufacturing point of view, everything looks absolutely spot on. Okay, so as you've seen, the VTX, as far as I can tell, achieves the numbers that Foxeer say it should achieve. In fact, both of the ones that I have do. I'm not going to say the results are 100% accurate, but they are certainly reflective of what I was expecting, and I've got no reason to doubt the specification that Foxeer has given on these. Now, just a couple of other things I want to mention before I finish this one up. This VTX gets extremely hot in use. You want to make sure that it is getting cooling. As I did show, it has those bolt holes at the bottom there. However, you need to make sure that there is airflow over this heatsink side of the board. This side does have those thermal pads that attach it to the casing. However, the main bottom board is on this side, and this is the side that is going to need cooling, but this side is as well. So my advice to you would not be to mount this flat on a frame. It needs a sort of mid-ear position where it's going to get airflow moving over it. Overall, I think it's a good VTX, and if you're looking for a high-power VTX for analog, there is no reason not to consider this one. It does seem to achieve what they said it should. Yes, it comes in a little bit more expensive than some of the other ones, but it does seem that you are getting that additional power for that money. So that is it from me on this one. If you have found the video useful, please do consider giving it a like. If you have any comments, please do put them in the comment section. I will try and answer any questions you may have. Furthermore, if you have found this video useful, please do consider checking out the link in the description to my Patreon. I want to say a massive thank you to all of my patrons who have supported the channel. We are not able to keep making content without your support, and I want to say a massive, massive thank you from me for the kind support you have given us so far. Anyway, that's it. Stay safe. I will speak to you soon.